Hello, my lovely logic friends, and welcome back to Dr. Logic awkwardly does logic in her office. The final component of our whirlwind tour of the Aristotelian syllogism is to show that of all of the syllogisms that we have, remember there's the 256 different syllogisms we can make, that the proof system we've developed doesn't prove any of the ones that are traditionally taken to be invalid. So if we are unable to demonstrate a proof of a particular syllogism, then it will be possible to construct an interpretation that makes the premises true and the conclusion false. Now, the interesting thing about what we're going to be doing in this video is that these results that I'm going to show you actually date back to Aristotle himself. Now, the way in which I prove it, and some of the names of the words and the symbols and things, not Aristotle, but the idea of looking at the proof rules that we have and then showing that you cannot construct certain types of proofs given the rules that we have, this is all in the prior analytics. So if you want a little extra fun exercise to do after watching this video, go back to the prior analytics, take a look at it, see if you can find where he gives these metaproofs. These proofs are interesting because they are the first meta-level arguments, so arguments about a logical system that we know of. So Aristotle is kind of widely held to be the father of the birth of Western logic because he's the first one to kind of explicitly write down the rules for reasoning that he thinks are good ones to use. But he's also important because he recognizes that it's not just saying what the object level rules are, the things that tell you what to do, but the fact that we can reason about those rules in this meta reflective fashion. So super cool and interesting. Hope you find it lots of fun. There are actually 5 different results that we are going to look at, though I'm only going to work the proof through, well, I'm not actually going to prove any of them, but I'm going to give you the flavor of how the proofs work, because they're going to be the same in each of these cases. So I will focus on one in particular as kind of our touchstone for examples, but all of the other ones you can prove yourself using exactly the same methods. So let me make sure I've got everything up in the right way and then share my screen, just so that you can see all of the theorems written up here on the left. So these are the results that we can prove, which will knock out as being unprovable and therefore invalid all of the syllogisms except for the 24 named ones that we've mentioned before. First, in our proof system, no conclusion can be proven from 2 negative premises. So if you have 2 E claims or 2 O claims or an E and an O claim, you will not be able to derive any syllogism in our system. Second, no conclusion can be proven from 2 partial premises. So again, if you have 2 I claims or 2 O claims or a mixture of them, you will not be able to prove anything from these premises. Third, no affirmative conclusion can be proven from a negative premise. So if at least one of your premises is negative, your conclusion also has to be negative. So you can conclude things from negative premises, you just can't conclude affirmative things. Number 4, no negative conclusion can be proven from 2 affirmative premises. So again, you can prove negative conclusions, but only if at least one of the premises is itself negative. And finally, number 5, no universal conclusion can be proven from a partial premise. So if you have a universal conclusion, both of your premises have to be universal. Other way around, if you have at least one partial premise, you have to have at least one, you have to have a partial conclusion. So all of the arguments for each of these 5 theorems that we can construct are based on looking at what the rules allow us to do and what the axioms allow. So we will not, like I said, I'm not going to look at any one of these in particular, but I'm going to kind of draw back and give you the overall picture of how we would go about showing each one of these different results. So the first thing to note is that every proof has to involve the application of one of the axioms. This is the only way that we will be able to get a syllogistic conclusion that contains one term from the first premise and one term from the second premise. So if we don't apply an axiom, we will never actually generate a syllogism. So the first thing to note, and here I think I'm going to stop sharing the slides and start sharing the whiteboard, just so that we can keep track of some of these important things to note. So, note. No axiom has two negative premises. So, Barbara and Dari each have two affirmative premises. Chalorant and Ferrio have one negative and one affirmative. Also, no axiom has two partial premises. So again, Barbara and Chalorant both have universal premises. Dari and Ferrio have one partial premise, but the other one is universal. Next, note that both Chalorant and Ferrio have a negative conclusion. Both Barbara and Dari have an affirmative conclusion. And lastly, both Dari and Ferrio have a partial conclusion. So what you can see is that these important facts that I want you to know share a lot of correspondences with the 5 theorems that we will be able to prove. So, both Dari and Ferrio have a partial conclusion. So this means that any proof from a pair of premises that are both negative or both partial will have to contain more than just an application of an axiom. Because if you have two negative premises or two partial premises, none of our axioms can be applied because no axiom has two negative premises and no axiom has two partial premises. So we will need to be able to apply one of our transformation rules in order to be able to apply an axiom. So 4 possible rules to apply. These are reiteration, simple conversion, accidental conversion, and the hypothetical method reductio ad absurdum. So first thing to note, reiteration takes a premise, writes it down again, doesn't change anything, so it will not help us. If we start off with 2 negative premises or 2 partial premises, reiteration is not going to change things. We will still have 2 negative propositions or 2 partial propositions. Simple conversion changes the order of the terms, but it doesn't change the copula. So after we've applied simple conversion, we will still have the same number of negative premises or partial premises. So simple conversion isn't going to change that at all. And it doesn't matter then how many times we apply simple conversion, it'll never change the copula. Accidental conversion does change the copula. It converts us from universal copulae into partial copulae. It also swaps the order of the terms, but order of the terms isn't what we're interested in here. However, accidental conversion will not change the quality of the proposition. It'll only change its quantity. So if it was affirmative before, it will stay affirmative, and if it was negative before, it'll stay negative. That's what the opposite of affirmative is. So the important thing to note here is that if we apply accidental conversion to 2 negative claims, we will still have 2 negative claims. The other thing to note is that accidental conversion cannot be applied to partial premises, and therefore isn't going to be something that will change partial premises into universal premises. So the last rule that we have is the reductio ad absurdum. Whenever RAA is applied, one of the premises will be reiterated into the subproof to be used along with the application of an axiom, along with the assumption that we have made. So you remember that the structure is, we've got premise 1, premise 2, we have our new assumption, some categorical proposition phi, and then either premise 1 or premise 2 will get reiterated. So if both of these premises are negative, then the assumed proposition will have to be, the assumed proposition is going to have to be the assumed proposition has to be affirmative, because we need to be able to apply some axiom here in order to get out of our subproof. And we already know that none of our axioms has two negative propositions. So if these are both negative, then this has to be affirmative, so that we've got one affirmative and one negative. So in that case, the only axioms that could be applied are Taylorant and Ferriot, both of which will give you a negative conclusion. But, sorry, this needs to still be in here. We apply our axiom, we get a negative conclusion. But no negative proposition is ever going to be the contradictory of another negative proposition. And this premise that we reiterated down here was negative. So if we are in a position to apply the axiom, the proposition that we generate won't contradict the other premise that we have. Now, if we are not in a position to apply the axiom, well then, there isn't really much that we can do. So again, note that in the context of this subproof, reiteration doesn't change whether we have universal or partial, positive or negative copulae. Simple conversion doesn't change the copulae. Accidental conversion only changes the quantity, not the quality. So the only other option left inside this is to use our axioms. So we could do something similar if, say, our two premises were, so if we've got premise 1, premise 2, if these are both partial premises, then so we're going to assume something. We reiterate one of the premises, say it's number 2. In order to be able to apply an axiom here, we have to be able to apply the assumption has to be universal so that we can apply either Ferriot or Darye. But then what we conclude here is going to be a I claim or O claim. But this partial conclusion cannot be a contradiction of the partial premise that we reiterated. So applying the rule here will not get us to something that we need. Applying the axiom doesn't get us to something that we can use to get outside of this reductio ad absurdum rule. So what we can show is that none of the axioms have the right form, and you can double check that each one of these claims corresponds to one of the 5 theorems that I showed you at the beginning of the video. We know that reiteration doesn't change the copulae into the right type. Simple conversion doesn't change the copulae into the right type. Accidental conversion can change quality or quantity, but not quality. And RAA requires us to be in a position where we can apply the axioms. If we weren't already in that position, making another assumption is not going to put us in a position where we can apply the axioms and successfully use reductio ad absurdum. So each one of these results, here, I'm going to bring them back up. That's this one. Come on, share. Each one of these results will knock out as unprovable another chunk of the invalid syllogisms. So what we can show with this system is that the system of proof that Aristotle developed in the prior analytics proves every syllogism that is traditionally taken to be valid, and we can show that this proof system is validity preserving. If you accept the validity of the axioms, everything that you can derive will be valid as well. But you can also show that this proof system doesn't prove anything traditionally taken to be invalid. Now, I haven't given you reason to think that all of these invalid syllogisms are invalid, but this is fairly easy if tedious. All you need to do is construct an interpretation that makes the premises true and the conclusion false. So, there you have it. This is the Aristotelian syllogistic. You've gotten the language, you've gotten the semantics, you've gotten the proof theory. You can now prove or disprove every single syllogism that you can construct out of the 4 categorical propositions and a term language of your choice. Aren't you happy? Isn't this just the best day of your life? But wait till next time, because I will get to tell you everything that the syllogistic can't do. See you then. Cheers.